let's look at this problem. So this problem try to illustrate when you are given a space curve, how are we going to find the equation of the line tangent to the curve? So we learned how to use a parametric equation, so a vector value function to express a line. And when you have a line that's tangent to a given curve, that's called a tangent line. Then how do we find the equations for this tangent line? Okay, so here I have RT sitting in the space. Let's say just make it more arbitrary. I don't know how it looks like in space, but let's just say this. Okay, and so this RT, this curve is governed by the function up here, and at t equal to 0, where is x t equal to? Let's say it's here. Okay, it's not really here. This is just for illustration. So this is the point where r of 0 is. So r of 0 is a vector, and the tip of the arrow, that's the point r of 0 as well. Okay, and we are then looking for the line tangent to the curve at this point. Okay, so what we don't know yet, but we have some information, is what is the direction of the line. Okay, but you know that it's the tangent direction, so you can get tangent direction by finding a tangent vector, right? So when you have a curve, you can find a tangent vector by doing derivative of the vector, right? So now with this, you have a vector that tells you the direction of the tangent line. And by plug in 0 into the t, why 0? Because it says at the point t equal to 0, so it's r of 0. Then here it gives us a point that the line passes through. And once we have a point on the line and direction of the line, then we can put things together to write down an equation of the line. Okay, so that's the idea. All right, so let me recap. First of all, I want to find the point r of 0. So this one is very straightforward, very easy. Just plug 0 into the t, and then you will find a point. 2. Then you will find the tangent vector, but you want the tangent vector at this point, so at t equal to 0. So what does that mean? Tangent vector is given by the derivative of r, right? The r function. And at t0, what you have is r prime of 0. So you're gonna plug 0 into the r prime, okay? And once you're done with these 2 steps, you have a point, you have a vector of the line. Then using these 2 ingredients together, you will be able to then 3 write down an equation. Okay, so that's the framework. This is clear, and that's just doing it step by step. All right. So First, r of 0 to the plug in. So the I component is the I vector is the x component, and the j vector gives you the y component, and the k vector gives you z component. So straightforward plugging in, that's what we have. And remember we talked about trig functions at the spatial angles. So you're supposed to know this. If you don't know how to find the values here, we have a supplemental video talking about trig functions at spatial angles. You should watch those. So this is 0, this is 1, this is 0. Great. So I have a very simple vector pointing towards the y-axis. Number 2, I go ahead and find this, so this is like the first half step 2, the second half step 2. All right, so now I go ahead and find r prime of t. I need to find the derivatives of these guys. Okay, let me write down r of t first so that you can see the comparison. So r of t is sine of t, cosine of t, and t squared. Now I want to find r prime of t, which is the derivatives of each component of t. Okay, so if you don't remember the derivative formulas, you should watch the review video about derivative formulas and derivative rules. So those will be extremely helpful for you to excellent the course. Okay, so make sure you do put an effort and memorize the list of derivative formulas. This is very important. Okay, you don't want it to be like you have to every time you go look it up and write down the solution, and look it up, write down another solution. That's just not enough. Okay, so derivative sine is cosine. Derivative cosine is minus sine. Derivative t squared is 2t. Okay. Okay. So now, so this is first half the step 2, and let's do the second half of step 2. Once we find a generic tangent vector formula, we wanna find this one, the one that's at the point r equal to 0. So then we plug 0 into this formula. So cosine 0 minus sine of 0 and 2 times 0. Okay? So simplify this. Cosine 0 is equal to 1, sine 0 is equal to 0, 2 times 0 is equal to 0. Great, we have a lot of zeros. So now step 3. Step 3, we can say the line can be expressed by this equation. Let me just put x of t, while t and z of t all together in the coordinates. Okay, so don't rush. Make sure you understand which is which. This is for the point on the line. So point on the line. This is for vector. That's the direction of the line. Okay. So it's always 0. Okay. Point plus the x component times t. Okay. Then y coordinate plus the y component of the vector, so 0 times t. Then for the z, so point times 0 times t. Okay, so this happens to be extremely simple final solution. So 0 times t, this is t. 1 plus 0 times t, so 1 plus 0, so that's 1. And 0 plus 0, this is 0. Okay? So we have, it's this. Okay. So we have x of t, we have t z of t equals t common 1 common 0, and this is an equation for the line tangent to the curve at t equal to 0. If we want to look for, let's say, another tangent line at t equal to, let's say, half pi, then you do the same process, but then you will evaluate t at a half pi. So here you have r of a half pi, and here you will have r prime of a half pi, and you put things together for the equation. Okay, I hope this is clear.